Okay, so today we're doing similar figures. Hopefully you've had a chance to practice your congruence one. Remember that congruence means that the shapes are the same in every way. Same shape, same size. But similar figures are the same shape, but they are different size. They've either been made larger or been made smaller. Okay, so the symbol for similarity is the 3 vertical lines. Remember, congruence was 3 horizontal, so similar is 3 vertical lines. And here is some similar shapes. And notice they're not triangles. So we're not always just restricted to triangles. We have some looking somewhat like trapeziums there. And it says to consider the following shapes. First thing we're asked to do is to write a similarity statement for the 2 shapes. So that's like what we do in congruence. We go like in triangle A, B, C, and D, E, F, that kind of thing, where we have to match the vertices. Okay, so we don't put a triangle symbol in, obviously, because they're not triangles this time. It's a quadrilateral. So the first quadrilateral, I'm going to do in alphabetical order, A, B, C, D. Okay, and then I use the 3 vertical lines to mean similar. Now when I go to my second quadrilateral, make sure the vertices match. So A matches with what letter? E. E, yes. B matches with H, and then G, and then F. Okay, so you will be asked to write a similarity statement in your test. That's what it means. Make sure your vertices match. Now, in similar shapes, as I said, they're either being made larger or made smaller. So we want to be able to compare what's happening with the side lengths. So in part B here, it says fill in the boxes. EH, which is this side here, this long one, over, and I've got a box there. I want to know what side it matches with in the slightly smaller one. AB. It would match with this one. Yes, make sure the letters are in the right way, and you did, good. So AB is the side that matches. Okay, then FG would be that one. It's going to match this one, but what way do I write the letters? DC, excellent. Okay, so we're comparing the side lengths. Now we want to find a scale factor. So that's how much larger or how much smaller we've made that shape. So I'm going to start with the big one, and I'm going to look at the side FE. And let me get rid of these other highlighting parts. I can see that this side FE would match that side there. They would go together, wouldn't they? So I'm going to use that to find my scale factor. I'm going to start with FE, and I'm going to divide it by the DA. FE is 10, DA is 4, 10 divided by 4 is 2.5. That means that that second quadrilateral is 2.5 times as big as the first one. Remember, they're not to scale. Okay? Then in part D and part F, we want to find some missing values that are on those quadrilaterals. Now, you can use the scale factor that we've already found, and you can either times or divide, but it's easier if you make the fraction each time, because then you can put the pronumeral on top where you want it to be. For example, let me show you what I mean. So if I'm trying to find x, which is what I want for part D here, x is this side here. I want that to be on the top of a fraction, so I'm going to make side x go over. It matches that side in the other one, which is 6. So x over 6 equals. Now I need another set of matching sides, no pronumerals, which I would use the 10 and the 4 again, which I know is 2.5, but we're going to put them in there. So 10 over 4. So if I start with, let me just emphasize, if I started with this shape, I go big shape over small shape, big shape over small shape. And when I do the next one, it's actually going to switch because I'm going to be doing the small shape first. So to solve that little equation, all I want to do is times that 6 across to the other side. I'm going to go sideways here because there's not a lot of space. x is equal to 10 over 4 times 6, which is equal to 15 centimeters. Okay, let's start again. Now I want to find y. So here is y up on the top of this little quadrilateral. Put that on the top. Whatever you're trying to find, you put that on the top of your fraction. So y on top, it matches the 12 in the big quadrilateral. Equals, go back to the small one again, and the small one I have the 4 over the big one, which is 10. Do you see how it's reversed now because I started with a different shape? Why? Because I was trying to find one in the big shape before, so I had to go big over small, and now I'm reversing it because I'm trying to find one in here, so it's small over big, small over big. Okay, so let's solve that. Times the 12 across, so it'll be y equals 4 over 10 times by 12, and that equals about 4.8 centimeters. Okay.